We are going to learn about the chain rule or how to find the derivative of a function using chain rule. Suppose a function is made up of a function itself. So to find the derivative, we find the derivative of the function fx with respect to gx, assuming gx as x, and then again we find the derivative of the function gx. Let's take some example to make it more clear. Suppose we have the first example as fx is given as x square plus x plus 1 whole square. Now we already know that the derivative of a function x square is given as 2 times x using the power rule function n x to the power n minus 1. Now x plus 1 whole square, instead of x we have a function which is given as x plus 1. So assuming the whole thing within the bracket, whatever is inside the bracket, I'm going to assume this as x. So the function is in the form of x square now. So when I find the derivative of this function, I'm going to use the property of power function. So 2 times x plus 1. Then again, I didn't have the normal function x square, but I had x plus 1 whole square. So I had, instead of x, the function is replaced by x plus 1. So again, I need to differentiate the function x plus 1. So, which is given as 2 times x plus 1 times the derivative of x is 1, derivative of 1 is 0, so just 1. So 2 times x plus 1 is the derivative of the function. We can also understand the same concept of the chain rule using one more logic. Let's say, for example, I want to solve the same question. The function is given as x plus 1 whole square, and let us assume this x plus 1 equals to u. If this x plus 1 is u, so the whole function, the derivative of the function d by dx of fx is d by dx of u square, but I need to differentiate it with respect to u. So d by du of u square, then again du by dx. So assuming this function as a single function, I'm considering it as u square. So derivative of u square is 2 times u, derivative of du by dx. From this part we can have the derivative of du by dx. So du by dx is going to be equal to 1. The derivative of u with respect to x is 1. So 2 times u times du by dx is 1. So 2 times u is substituted as x plus 1 times 1 gives us 2 times x plus 1. So either I use the first concept to solve it, or I use the second concept to solve it. This is how we apply the chain rule. Let's look at one more example. Suppose it's given, the function is given as ln of x square plus 1. I'm going to discuss second example now. The example is y equals to, say, ln of x square plus 1. So dy by dx equals to, assuming everything as x, derivative of ln x is 1 over x. I know that the derivative of ln x is 1 over x, so I have used that property here. Then again, I don't have x, but I have another function, so the derivative of the function which is inside for using the chain rule. So 1 over x square plus 1 for the first part. For the second part, the derivative is 2 times x, so the overall derivative is 2x divided by x square plus 1. Let's look at the third example now. Third example is e to the power 3x plus 4. Suppose we have y equals to e to the power 3x plus 4. we know that the derivative of e to the power x is e to the power x. So, assuming everything is x, dy by dx equals to e to the power, assuming everything is x, but that is not x really, so I need to find the derivative of that function also. So e to the power 3x plus 4 times derivative of this part is 3, derivative of 4 is 0. So that is the answer for the question, and this is how we apply chain rule for finding the derivative of a function. Thank you.